Cool. Okay, so this is considered an equation with variables on both sides. Okay? But we framed this. I framed this 2 days ago in the same lesson as we're combining like terms, right? We're combining like terms. So what's the difference here? How do you have to combine like terms if the variables are on both sides? All right, so we want to get them on one side. That's good. That's correct. Guys, shh. We started, okay? We got to get them on one side. You can't solve for a variable that's in multiple locations. For example, here's the silly sci-fi analogy I like to make. When an evil villain has cloned himself in a climactic battle at the end, how does the hero know which one is the real one? You can't until you get them narrowed down to just one. Okay, so all the like terms have to be combined into a single location. You have to kill all of them until the only one that's there must be the real villain, right? I feel like this was maybe like a Fantastic Four thing or.
Fantastic Four. I want to see the first one.
All right. Anyways, enough about that. You guys are getting off track. That's my fault. I thought it would help. Nonetheless, Quentin's right. We have to get all the variables in one location. Now, does it matter if we do it to the left or the right?
No.
It does not matter. But personally, you can have your own preference here. You're allowed some freedom in math. I like to keep the variable positive. So I'm going to look forward and think, okay, if I subtract 5 from both sides, that's going to make the x negative. So I don't want to do that. I want to subtract 4x from both sides. Okay, now why did I subtract? Well, that was related to my first question. When you have to combine like terms on opposite sides of the equal sign, I'll give us kind of a little dividing line here. You have to use the opposite operation. Okay? You guys can pay attention when other people are in the room. It's okay. So we'll subtract 4x from both sides. This is the reason we have to use the opposite operation, is so that it will cancel on one side. Okay, now, how did I know to subtract? This 4x is positive. No, there's not a plus sign here. We understand it to be positive, though.
Because if there's not, can you draw one?
No. So, what's left on the left side? 6, and then I can combine this, right? But I think you guys can handle this. I'm going to deal with the 6 or the 7 now, too. Okay? So, even though we could go ahead and write the next step here, I know that I have to get all my constants together, right?
Yes.
So, how am I going to do that?
You got a minus 6
from 7.
All right, so Luke is correct. Because if I subtract the 7, then that'll move it over to this side. Why do I want to do that? Because I've moved the x's over here. That means I want to move the constants over here. So we'll subtract 7 over here. We'll subtract 7 over here. So I can do it all on a single line. If you want to split it up into 2 steps, that's fine too. I'm just limited on paper today. So, cancels out. Now take a look at what we've got here. 5x minus 4x. 1x, which is just x. Right? And then 6 minus 7. Negative 1. Am I finished?
Yes.
How do I know that I'm finished?
Because it's just one.
Because x is
by itself.
isolated or by itself. Okay, again, that's what it means to determine what the value is to solve for the variable, to get it by itself.
Looks like a mushroom.
Cool. Okay, so if we go in and we plug that answer in,
It's going to be wrong.
That'd be funny.
you can see the same steps, but in a different order. And they also, you guys see that they move the x to the other side. So they got the same answer a slightly different way, but all the operations are still basically the same. Okay? We're moving all the x's to one side. We're moving all the constants to the other. All right? So, having that in mind, some folks said that they had some questions about the homework. So we'll start with that before we go over any other Delta Math sections you'd like for me to go over. So, was there a question mark that you guys left on some of the homework from 94 and 95 that you'd like for me to go over? 94 again was on like terms. We had a couple of different strategies for that included highlighters or colors.
Oh, 95 against 20.
95, 20.
Did you need to do my homework?
Yeah, I'll get it eventually. Anything else? Anything on 94? Anybody have questions about lesson 94?
What was 94 again?
Combining like terms?
Yeah, I have a ton of questions. But I don't know.
What about 95 besides 20? Finna let me know about number 20. Anything else?
I think there was one.
Are you guys just happy I'm not giving you semicircular, cylinder,
Yeah.
prisms?
Well, that too. I think.
Luke, did you find it?
No.
All right, so 95, number 20, 2x minus 5 equals 9x. So this is just like the warm-up problem we did. Let's see if we can follow the same logic, okay? So, I see x and 5 over on this side. On the opposite side, I have x's. So I only have one constant. It's going to be best if we just leave that there. Well, if we're going to leave this here, then what should we do to proceed in the problem? All right, I don't want to... You could do that. There would be nothing wrong about that, but it would be unproductive.
You gotta subtract 2x. Right?
I want to subtract 2x. That will be productive because I want to move all x's into the same location. Okay. Again, why do we subtract? Because this 2x was positive. So we'll cancel. I have negative 5 equals 9 minus 2 is 7 x's remaining. So I had 9 x's. If I take 2 x's away, there's only 7 left. Now it's a one-step problem. If I realize that the 7 is multiplying, I'm going to divide to cancel it out. Negative 5 sevenths equals x. Yes, you can leave it in a fraction. Did I write it correctly? All right. So, lesson 96 was just a combination of 94 and 95. So just a quick recap of lesson 96. What we're going to be doing is combining like terms. And I'm going to give you the order that you should do that in before we do a couple more examples. You want to do that first on the same side. Whoops, on the same side. And then you want to do it on opposite sides, okay? So you want to combine like terms on the same side of the equation before you start canceling things out and moving them to opposite sides, okay? In my experience, many students get this mixed up. If I don't make a concerted effort to tell you, do it on the same side first. Okay, they get in such the habit of doing the opposite operation that they end up applying that the wrong way. So I'm sometimes hesitant to do that. I'm hesitant to show you what that is because I don't want you to do it. So we go ahead and preface. Don't write this next part down.
Okay.
Just watch. Here's what I mean by the wrong approach. So what they'll do is they'll look over here and they'll think, oh, to combine these, I got to do plus 3x and plus 3x. Now, what's wrong about that? That left side is just an expression. It's not an equation. If you cover up the equal sign, it's just an expression. And this clearly says 2x plus 5 minus 3x plus 9. The opposite operation is not applicable here because that's wrong. That's not what you're being told to do. We can see that that's wrong if we rewrite the original expression. Remember, you can change the order as you like. This is what you're supposed to do with that left side. Remember, I told you not to write this part down. So the opposite operation is not supposed to be applied here. It's not right. That's the only way I know how to say that. It's not right. Okay? So you don't do that on the same side. On the same side, you just combine your like terms like we learned yesterday in lesson 94. It's not until you get to the opposite side, moving things to the opposite side, that you use the opposite operation. I'm trying to make a really clear connection there by saying that very slowly. For the opposite side, you have to use the opposite operation. Okay. So, having said that, let's take a look at an example from lesson 96. All right, now it looks long and laborious and kind of silly, but laborful, full of labor. All right. So, again, if you did write down the steps I said earlier, combine like terms on the same side first. So, again, if you want to cover part of it up with your hand, you want to put a piece of paper over it, whatever you need to do, you don't have to do either of those, but you do need to work one side at a time. So, I'll focus on the left side first. I'm going to use colors since I got them handy. Get it to focus. Yeah, there we go. So, I've got 2x and I've got positive 8x over here. I've got minus 5 and minus 9. Again, which are treated like a negative 5 and a negative 9. And remember, this was called combining like terms. So, you could think about it like plus negative, plus negative. It's the same thing. So I have 2x plus 8x. What does that simplify to?
10x.
Okay, so I have 10x. Sounds like a racket. 10x racket.
What is a 10x bracket? Sounds like you have a
10x racket. Okay.
What is a 10x bracket?
A bad joke. That's what it is. So negative 5 plus negative 9. Or if you want to say negative 5 minus 9, it's the same thing. It's negative 14. Okay, so those combined exactly that way. Come on, camera. You can do better. Okay. Then I'm going to write my equal sign and realize I'm done with the left side. I'm completely finished. Now I'm going to work the right side. All right. The x and the minus 8x. Those go together. And they can become, well, I have 1x take away 8x.
Negative 7.
Negative 7x. What about the plus 5?
Keep it.
Keep it. Great idea. We have to keep it. It doesn't disappear, but it has no one to combine with on this side, so it's just going to tag along like a fifth wheel does. And it was just coincidence that that's the number 5. So, now that we have each side individually simplified, now we can start moving to the opposite side, which means we'll use what?
Confusion.
Opposite operations. Opposite operations. So, do you want to move the x's to the right or to the left? Doesn't matter. You pick. Okay, so if I want to move all the x's over here, the 10x is going to stay, and I'm going to move the minus 7x. How am I going to do that?
Add 7.
Add 7x. Very good. Very good. What happens over here? Cancels. 10x and 7x combined makes 17x. Now that I have decided, based on Luke's recommendation, that all the x's are over here, we want to move the constants over to the right side. How do I do that? Well, 14 and 5 are the constants. It's 14 is negative. I'm going to add the 14 since it's negative over here.
Oh, I didn't even see a negative. This is just blue.
Sorry, I won't use the blue anymore. Now you notice, look at how much simpler it's getting with each successive step. It's one step left because that canceled. We're going to divide by 17 and we're going to be finished. You mean I get to stop here? Yes. You don't have to find out what 19 divided by 17 is with long division.
1 and 2, 7. Okay.
Okay. Certainly don't have to give me the decimal approximation, but that's less than 96. That's it, guys. Work each side one at a time.
Hey, we're done with math, right?
Oh, I haven't taught the last lesson.
Wait, this is the last lesson.
No, 103 is. I decided that we would do 103. And I didn't add any homework in your book from 103, but I did tack it on to the Delta Math. So, any questions about this one? Do you guys want to do? Well, we're going to do some more on the whiteboard, the quiz is practice, okay? So I just want to kind of give you a short snapshot of lesson 93.
93.
I'm sorry, 103, my bad. The distributive property. All right. So, does anybody have a parent that works in the distribution of goods of some sort for a company? Well, company. Country. Sorry. What does the word distribution mean?
Distribute.
What does that mean?
To hand out. Give out.
Okay, to hand out something, right? To distribute. That's kind of like, it's hard to put another meaning other than what that word is, right? But if I said, okay, I'm gonna on Monday, I'm gonna distribute your exam reviews, right? Who would get one?
Me.
Everybody.
Me.
Okay? Everybody. So that's the connection I want you to first make here, is that to distribute means
To give out.
everything will receive whatever is being distributed. Okay? All right, so suppose I was going to give out candy, right? For it to be fair, I'd have to distribute it to each of you.
But what if some people don't want it?
Well, it doesn't matter. Go with the fairness idea for right now, okay? Or we can go back to the
Well,
exam. We can go to the exam. Doesn't matter if you don't want it. You get it.
Fairness isn't good because communism's not good. Communism is fairness, isn't
I doubt it. I don't think so. No. All right. So, is this mine? I'll leave it here. Sorry. Okay. So again, surface level, to distribute means to hand out, to visit, to give out fairly, equally distributed. Okay. So let's say I was going to give candy
it? 5, 7.
to Luke and Avery and Ella. All right, now you notice, where's the multiplication from? Just go with it, okay? This is what I want you to understand, that the distributive property means. If these are the only 3 students, right, and I'm saying candy times these people, right? Why did I add them? Because they were a combination. They were just the group that happened to be there, okay? What would the candy be multiplied by? Okay? Specifically, these 3 people, right? So here's what I want you to understand about the distributive property. The candy is going to be distributed to Luke and Avery and also to Ella.
I'm pretty sure I did this in 2nd grade.
Good. So, why am I showing you this? Well, what we can understand this to mean in simpler terms, we can get rid of the parentheses by writing it this way. Candy times Luke plus candy times Avery plus candy times Ella.
Oh yeah, I did this in 2nd grade.
Okay.
We use a little base 10 blocks. When we use them.
I won't be using the blocks, but that was probably in an effort to help you kind of understand what you were going to do. So this is distributive property, guys, in a nutshell. I'm going to give it to you in much simpler symbols in just a second. But that's it. That's all the distributive property means. Now, how does it affect us in math? Because it doesn't really look like math just yet.
Well, you add the numbers.
Let me give it to you this way. If you were to try and multiply A times B plus C. Okay, again, A, B, and C can be numbers. They can be variables. They look like variables right now. What that's going to equal is A times B plus A times C.
We used to split up numbers like this.
Yes, this is a great way to learn how to multiply large numbers.
Like it was like 152 and then we did 1 times 100, 1 times, and then it was like 5 times 10.
Right. So if you wanted to multiply 17 times 9, you could do 9 times 10 plus 9 times 7. 153. It's much faster that way, right? That's how probably myself and the other John do it quickly. Is that we do distributive property, we break it down in our heads. It's not that well, I won't speak for the other John, but it's not that I'm some math whiz. It's just practice and knowing some principles that you can break numbers apart and do them faster. The base 10 part that you were talking about, Luke, that's all I'm doing. Yes, sir.
Who's the other John? There's a lot of Johns.
The other John Von Cannon. The only John Von Cannon.
The other John Von Cannon?
Sorry, the other John is John Von Cannon. All right. Hopefully he gets to watch this video at home. I'm just kidding. So, this is distributive property. I mean, is that all there is to it? Yes. Basically, any number that's multiplying in parentheses has to distribute to each quantity inside the parentheses, okay? So, example 1, we can do something really basic. We can say 2 times x plus 4. 2 times x plus 4. Now, let me show you a really clear picture of the distributive property to help you remember it. Suppose we had a rectangle that had a height of 2 and a base of x plus 4. It's not going to make it harder. 2 and x plus 4. Now I get it. We don't know what x is, okay? But the way I have drawn it, this is going to be a really clear picture. If you know that the area is base times height, and you understand the distributive property is 2 times everything in here, then all we have to do is separate the x and the 4. 2 times x, what would that be?
2x.
2x. 2 times 4, what would that be? 8. So the total area of this rectangle would be what?
2x plus 8.
2x plus 8, right? The area of the two sections would just be the combination of those two sections.
Wait, so what did this say in 3rd grade what you did? So like a distributive property, do you do like box this?
Yeah, kind of like this?
No.
No, not like this at all?
Yeah, sort of like that, I guess. But it was with actual numbers.
So this is also one way you might have learned how to multiply large numbers. It's distributive property, but it's an area model. Okay? So that's really all distributive property is. Now, do you have to draw a picture every time? No.
I like drawing.
If you want to, that's fine. It does help you understand what distributive property is accomplishing. Okay? I can show you in even without a variable. Okay, does anybody still writing? This?
Oh, no.
Okay. All right. So, suppose you were asked to write, and again, this may be what Luke was talking about. Suppose you were asked to find the product of 28 times 47. All right?
Yeah,
So what we would think about this guy. Look. Come on. We're going to split 28 up into a base 10 number or something that ends in 0 and a 1, a 1's value. So we'd say 20 plus 8. For 47, what would we write there? 40 plus 7. Now, again, if you think about this as an area problem, we're going to have 20 plus 8 and 40 plus 7.
Yeah, that's what we did in 6th grade. Isn't this what it's not to do in 5th grade? And we need to do the other ways to solve it.
Yeah, it's a toss-up. Let's just put it that way. Okay? Now this one takes up more space, probably, but this is also very simple to do in your head. 40 times 20, well, you just do the 4 times 2. That's 800. And then 40 times 8, that's 32 with a 0. 7 times 20, that's 14 with a 0. 7 times 8 is 56. But what do you do with all of these now? You add them all up. So we say 800 plus 320 plus 140 plus 56. $13.16. Now, what on earth just happened? Let me show you what you can think about in terms of why this applies here. So, if I were to say the 20 times 40 is right there. Luckily, I have 4. The 20 times 7 is right there. Now, think about that. The 20 and the 8 had to both distribute, or the 20 had to distribute to both the 40 and the 7. Now, well, 8 times 40. That's the 320. And 8 times what's left? 7. 56. So if anybody has an older sibling, they probably learned something called FOIL, which stands for first, outer, inner, last. It's a way that helps them remember how to multiply something like this. Now, we're not going to do this. But this is the algorithm, which is really just a process, for how to multiply something like that. You do the first terms, the outer terms, the inner terms, and the last terms. Why do we do it this way? Because this is what is illustrated by something like that. Okay? All right, where are we going to use the distributive property? We're going to use it in equations. Okay, so I'm going to pull up some of the delta math, and then I'll write the problem down. Okay? I'm going to pull up the tape diagram model. Tape diagrams, yeah. Y plus 7, y plus 7, y plus 7. $54. Okay, so if that's what we're looking at, we're going to do two things, right? The delta math just wants you to choose the equation. We're also going to solve it. But how would we write an equation with the distributive property in mind? Okay, because your answer choices are going to require you to have a parentheses. So you see each individual piece is a y plus 7. How many of those are there?
3.
There's 3. So can I just write this? No, because what does this say as written? There's 3 y's and 1 7. So how would I group the y plus 7 together? The natural thing for math is a parentheses. And then we can say, okay, those total up to 54. Right? Now hopefully, if you wrote this, you would know that it was wrong when you looked back at this one, because you see 7 plus 7 plus 7. That had to be 21 somewhere. There's no way I'm going to get a 21 over here. So that would be wrong. But if you think about this, where does the 21 come from?
The 3, 7.
What is the 3 going to do to the 7 over here?
Multiply.
Yeah, so it's going to visit or distribute to both the y and the 7. So what is 3 times y?
3y.
What is 3 times 7?
21.
And since it's a plus 7, it's going to be a plus 21. Now, what does this look like? This looks like a two-step equation from like 15 lessons ago. Okay? So you subtract 21, 33, y is 11. Whoops. Okay? All right, but wait. There's more. So instead of doing this, all right, look. You don't have to write this next part down, because when I started teaching this way the last 3 or 4 years with other school, it got confusing, because I was like, wait a minute, you could do 2 things? So if you understand this, this will be super helpful moving forward, okay? You won't get the blanket pulled over your head with simple problems that confuse everybody else. What is the 3 supposed to be doing to the parentheses?
Multiply.
Okay, but if instead I chose to cancel it somehow, how would I do that?
Divide y plus
Sin-
7 by 3.
Divide both sides by... So instead of distributing to get rid of the parentheses, which does work, as you saw over here, does and always works. So you don't have to learn this, but I think it's better if you do. You can choose instead to divide both sides by 3, because this 3 is multiplying this quantity. Now again, you don't know what that quantity is, so simply putting everything under 3 will cancel out that 3. And I'd be left with y plus 7 equals 54 divided by 3. That's 18. Minus 7, y equals 11.
What?
So,
It's the same thing. You just put parentheses there.
well, it's not, I mean, it's the same answer, but it's getting rid of the distribution a different way. Not distributing, I should say. Instead of saying, okay, the 3's got to go visit this grandma and this grandma and this grandma, like on Christmas, you just cancel that part out.
But like,
That sounds sad, doesn't it?
didn't we learn it a while ago?
This?
Uh-huh.
No, not with the parentheses.
It looks the same as either.
Use either one. Use either one. All right, so that's really all we're going to do with the distributive property is learn what is it, right? Again, it just, you can think about the area model. It just means whatever's outside has to go in and visit or multiply every entity, every number inside. So one more example before we practice with our whiteboards here. 5 times x minus 1 plus 2 times... Let's just ramp up the difficulty a lot.
What? What does ramp mean?
Increase.
What if you ramp down? What does that mean?
No one understands that. I'm gonna ramp down.
Let's say simmer down. All right, let me make my parentheses very obvious so that you don't think that they're ones. Okay?
Yeah, I was wrong and think there was myself.
We both got something to work on.
Handwriting. That's me. Terrible. Started out good in the school year, and it's got worse.
If it's notes, you just have to be able to read it.
My handwriting used to get better every year. My handwriting used to get better every year, and in third grade it just went down.
All right. So, you think about this for a second. You see 2 parentheses, 2 sets. So we're going to have to do the distributive property 2 separate times. Okay? So, again, you don't have to do the little arcs. That's just probably something I learned when I was your age and just continued to do, and that's what most teachers do when they teach distributive property, is that the 5 is going to multiply to both the x and to the negative 1. So what would that first part become?
5x. What? Oh, that's negative 5.
Minus 5, yes. Okay, all right. Plus. Now the plus, yeah, it belongs to the 2, sort of. It tells you that the 2 is positive, but we can just kind of treat the 2 like a positive anyway, regardless. So 2 times 3x, 2 times 1. So what is 2 times 3x? That's like 3x plus 3x, or 6x. 2 times positive 1?
2.
Positive 2. Now you look, okay, well this is just like lesson 96. Are there any like terms to combine over here?
Yes.
On the right side? With 81? No. Not by itself. But there are some constants that we need to move over there. And I think that's what Luke was probably thinking about. So, before we do that, huh? Okay, I'm sorry. Before we do that, we want to simplify this left-hand side. Okay? So what is it that we need to combine here?
5x times 5 and the 6x, or 5x and the 6x.
5x and the 6x. So the 5x is positive, the 6x is positive. We're going to get 11x. right? So I can put circles around those. Remember, that was one of our strategies. I can put underlines for the constants. -5 plus 2, -3, and then, okay, that's set equal to 81. Is it all right with you guys if if I change this number to 85? We haven't done anything with it, so just write over that 1 and make it an 85. Okay? You'll see why.
Because 85 is a
So, what are the remaining 2 steps? We're going to add 3 on both sides. So bring down everything that didn't move. 85 plus 3, 88.
That's what.
Last step,
X.
divide by 11. So a fraction is division. Make sure you don't forget that. My 4th grader's learning that right now, and I'm going to make sure she's good at it. So x equals 8. That's why I changed it to 85. Okay? So that's it. That's it for Algebra 1/2.
Okay.
Can we go back?
That's it.
Okay.